Imagine a message in a bottle, right? Except this bottle was tossed into the cosmic ocean almost half a century ago. It's traveled farther than anything humans have ever built, through places we've only ever dreamed about. And just when we thought its journey was basically over, it sent back, well, an impossible message. And what it said could change everything we thought we knew.
Now, the messenger here is Voyager 1. And you have to understand, this thing is an absolute relic. We're talking 1977 technology. Your phone's calculator, not even your phone, just the calculator app, has more computing power. Seriously. It was only built to last a few years, maybe send us a couple of nice pictures of Jupiter and Saturn, and yet somehow it's still talking to us.
And it's talking to us from 15 billion miles away. Let that sink in. A signal from Voyager, moving at the speed of light, takes more than 20 hours just to get to us here on Earth. That is an almost unimaginable distance, way out past Pluto, deep in the dark, empty space between the stars.
So from that mind-boggling distance, this ancient piece of tech sent back data that was so weird, so completely unexpected, that a Nobel Prize-winning physicist actually issued a warning to the rest of the scientific community. The data basically suggests that our most fundamental ideas about how space works might just be incomplete. So what on earth did this ghost from the 70s find out?
To really get the message, you first have to appreciate the messenger. I mean, the story of how Voyager 1 even managed to survive long enough to send this data, it's a flat-out miracle of engineering, mixed with a little bit of cosmic luck.
The whole mission was only possible because of this super rare planetary alignment they called the Grand Tour. It only happens once every 176 years. This let Voyager use the gravity of Jupiter in 79 and then Saturn in 80, like a massive cosmic slingshot, flinging it out of our solar system on a one-way ticket to the stars. One tiny mistake in navigation and the whole thing would have been a bust, but they nailed it.
And to survive out there in the dark, Voyager was built different. No solar panels. It was too far from the sun. Instead, it runs on what's basically a nuclear battery, powered by decaying plutonium. Its signal, by the way, is now weaker than the light bulb in your fridge. For decades, engineers have been carefully shutting down its systems, one by one, just rationing every single watt of power to keep its tiny voice alive.
So Voyager was heading out into true interstellar space, a place no probe had ever gone before. But scientists, they had their models. They had expectations. They thought they knew what it would be like out there. They expected a whole lot of nothing. A great quiet.
And to see why, you gotta know about the heliosphere. Just think of it like a giant magnetic bubble that our sun blows out into space. This bubble wraps around our whole solar system, and it acts like a shield, protecting all of us from all the nasty radiation coming from the galaxy. So scientists expected Voyager to cross a pretty clear, sharp boundary where this bubble ended, and then it would just be in the calm, predictable quiet of interstellar space.
Yeah, that is not what happened. Not even close. The reality was a total shock. Where they expected quiet and calm, Voyager found a place that was dynamic and buzzing with activity. That clean, sharp boundary they were looking for? Nope. It was actually this messy, overlapping, chaotic zone. The universe, it turns out, just wasn't playing by our rules.
Okay, so let's get to the good stuff. What was this so-called impossible data? What was so surprising that it threw decades of scientific theory right out the window? Voyager didn't find aliens or some giant scary object. No, it found something way more subtle and honestly way more profound. It picked up these unexpected plasma waves. It's almost like the space between stars was humming. It measured particles doing weird things and magnetic fields that just did not line up with our models at all. But the biggest discovery? The edge of our solar system isn't a hard line you can cross. It's more like a region, a place where our solar system just slowly dissolves into the rest of the galaxy.
The new reality is that it's not some neat ending, it's a transition. It's a place where the sun's influence starts to fade out, and the forces of the galaxy start to push in, competing and overlapping. And Voyager is our first witness to this cosmic blending. A place we thought would be simple, but turns out to be incredibly complex.
Now, this isn't just some weird puzzle for astrophysicists to chew on. The data from this dissolved region has real-world implications, and that's what got that Nobel Prize winner to sound the alarm. So, why does all this matter so much?
The impossible part isn't something that Voyager saw. It's the fact that Voyager is still working and sending back good, clean data that quietly, consistently, and stubbornly refuses to fit our predictions. The data isn't wrong. Our models are. They're just incomplete.
So the consequences here kind of build on each other. First, we know our models for interstellar space have big holes in them. Second, That means our protective shield, the heliosphere, is way less stable and predictable than we ever believed. And what does that mean? Well, third, it makes any future interstellar travel much, much more complicated and dangerous than we ever assumed. We thought we were planning a trip across a calm lake. Turns out, we're heading into an ocean with unpredictable currents.
And here's why that actually matters to you and me, right here on Earth. The shape and strength of that heliosphere shield is what decides how much dangerous galactic radiation gets through to us. If that shield is weaker, or more full of holes, or just more unpredictable than we thought, well then our planet's long-term safety is less of a sure thing. Voyager's data has a direct impact on the story of life on Earth, just on a much longer timescale.
You know, at the end of the day, Voyager's most profound message isn't really about plasma waves or magnetic fields. It's more of a philosophical lesson, a little reminder about how science is supposed to work in the first place.
Look, we've always known the universe is a weird place. That's not a surprise. The impossible discovery, the thing that really hits home, is that a 45-year-old probe, with its power fading, could so clearly teach us that our confidence was maybe a little bit premature. It's a lesson in humility, delivered from 15 billion miles away.
So, after all of this, right, after the grand tour, the decades of near silence, and this shocking new data, what's the single most valuable thing that Voyager has sent back to us? It's not a picture. It's not a number.
It's this: productive, uncomfortable doubt. That noble warning, it wasn't about panic, it was about being humble. Voyager forced science to reopen a chapter we all thought was closed. It reminded us that the whole point of exploration isn't to get all the answers, it's to learn how to ask better questions. And you know what? That might just be the greatest discovery of all.